Hey guys, should be a few of you guys now and there. So thanks for coming back. We are having a few technical difficulties, which is why we didn't get the live going right away. But we are here. We made it. Took a little bit. So I haven't seen anything pop in the chat. So let me just see if folks are over there. Make sure everything's working correctly. All right, I see my own post. So you guys are out there. There we go. What's going on? All right, so we have a special guest today. So we're talking about aquaponics, which is not something I know a whole lot about. So I reached out to some comrades and got in touch with an old friend, and he's here to talk about stuff I don't know about. So I'm going to be learning along with you guys. So let me introduce the Solarpunk Farmer.
What's up, everybody? Can you hear me all right?
I can hear you fine. So.
All right, awesome. Let's go Solarpunk with some aquaponics. I think aquaponics is a great example of a very Solarpunk technology. You can do so much with it. It's a super exciting way to grow food, honestly. And I have this slide deck prepared for you all, and it's going to be a nice, long, information-packed presentation. So buckle up. Make sure you're ready to receive, I guess, like, prepare to be bombarded with information is all I got to say, because I like to sort of pack it in. But I can go ahead and share my screen and we can get started with the slide deck if we are ready, Andy.
Yeah, I think so. Yeah, is there anything else we need to touch base on before we get going? I don't think so. Oh, actually, unrelated. Just for our patrons to be aware, we've got these. If I can hold them the right way. Nope, that's not the right way. These are our new patches that'll be coming out soon. I just don't have time right now to sell them, but they will be coming out in the near future. So I know people are a big fan of the Fire Beaver, so I'm imagining a few people want to get some. So yeah, I'll hand it off to you. Get your slideshow going, and I'll ask questions and try to grab folks from the chat as they have questions as well.
Yeah, sure. Stop me for questions anytime. It's going to be a lot of information, so we can. And if anything's not clear, then we can. I can answer some questions. Can cool. Everybody see the slideshow? Okay.
Hold on. Let me get you up there for you.
Yeah. Cool. Yeah, there we go. Yeah, I can see that. Perfect. I always love talking about aquaponics. It's not all that I do. Looks like there's a typo right there. What have I done? The Solarpunk Farmer. That's funny.
I think you might
anyways,
be onto something
I like to call this presentation "Sticking to Your Roots." What's that?
So I think you might be onto something there. Solarpunk. It's the new one. Better than Solarpunk. It's like the slow movement, but with Solarpunk.
Yeah. I love it. But yeah, this is called Sticking to Your Roots, DIY Aquaponics 101. And so we're kind of going to get into the very, very surface level of aquaponics today, and just sort of go over like what it is, how it works, sort of like, you know, in a way even how it's similar to like both soil and hydroponics, because it sort of merges those two worlds in a very interesting way. We're really just going to get into like, you know, the basics, like how to build a basic system, like where to start if you're looking to get into it, because it is a very difficult thing to master. So you're going to want to, I guess, start with aquaponics by dipping your feet in the water, so to speak, instead of building a massive system and just going like, I'm going to try and run this system. So we'll get into that, how to build a basic system as well. Just a bit about me. I guess you can call me an internet personality. I make YouTube videos now and then. Haven't been able to put out many videos lately. I've been pretty busy, but I do videos. I do memes on my Instagram. My YouTube link is down there. And I also have an extensive background in urban agriculture. I've been gardening for about 10 years now, and I'm in the Los Angeles area. I have worked extensively in the urban agriculture scene here through various nonprofits and organizations. I've done a lot of aquaponics work especially. But I've also done just traditional soil gardening as well, organic soil gardening, whatever you want to call it, all the buzzwords nowadays. And I also have been studying environmental philosophy and politics for a while. So I guess, you know, the question we always start with if we're trying to grow plants at all is, what do plants need to grow and thrive? And I'm sure you guys know this: light, water, oxygen, carbon dioxide, a growing medium, your nutrients, and in most cases, beneficial biology. I think personally that the biology is very important. In certain situations, it's not going to be as important. Like, for example, if you're doing hydroponics, which we're going to talk about very briefly, but it's very important both in soil and in aquaponics. So the way that plants normally acquire the means of their existence is with the soil ecosystem, and which is pretty much, and soil is pretty much the foundation of all terrestrial ecosystems, of course. And it is a living system. It is a biological community that supports plant growth, and plants in turn support the soil. I'm sure many of you know about the soil food web, and in aquaponics there is an aquatic food web as well. I'm not going to get too much into the ecology of aquaponics today. We're just going to be covering like the surface level of like what the aquaponics microbiome is, how it works, how it manages these different chemical compounds that exist in the system. But it does sort of like mirror how the soil food web functions, which is pretty cool. So growing in soil doesn't always make sense. And I can tell you that as an urban gardener, like you might have soil that's contaminated, for example. You might be on a rooftop where there's not any soil at all, and it's going to be expensive and difficult to haul soil up there and maintain raised beds and be constantly bringing like amendments, trying to run composting, a big composting facility up on a rooftop. Like that's difficult. You know, there might be some situations where you're just on asphalt. And again, like, you know, it's a pain to get a soil garden going there. So it's not always going to be practical. And of course, in urban environments, which is where aquaponics really can see, I think is best applied. Soil is limited to begin with, whether it's safe to grow in or not. Like many people don't have a lot of space, and it does take a lot of space to get a fairly substantial harvest out of the soil garden. Not so with aquaponics and hydroponics. And so they both fall under the hydroculture umbrella. And hydroculture is a broad term used to denote various methods for growing crops using water instead of soil as a primary medium. And of course, water is a part of the soil system. But in hydroculture, what we're really doing is we're cutting out that mineral matrix and soil organic matter and replacing it with a water-based medium. And of course, hydroculture has existed for a very long time. This is not a new technology. I'm sure many of you guys are familiar with Schematic systems. I'm trying to get the pointer up. The Schematic systems of Tenochtitlan, the city, and probably butchered that pronunciation, but what is now called Mexico City, and some of the Chinampas are still around, and these are amazing systems for growing food, and what I would say is the precursor to what we would call aquaponics today. A very similar system is employed throughout parts of China and Southern Asia, these floating raft gardens. This is in Bangladesh, and essentially they're floating gardens that are constructed out of water hyacinth and manure and then planted out with crops. And of course, probably the most famous example that we all learned about in school, it would be the Hanging Gardens of Babylon, which was pretty much a giant manually operated hydroponic system. So, you know, was thought. What I guess, you know, archaeologists now think is that it was probably one of the first examples of a hydroponic system. So what is hydroponics exactly? So we're using a soilless medium, so either we're going to be growing our plants directly in water, so the roots will be dangling directly in water, or in an air-water mixture, or a physical rooting medium. So we might have some kind of air-water mixture. That's what aeroponics is. We might have directly in water. That's what deep water culture is. And there are also other methods that use some kind of rooting medium that is a soil substitute, that is inert, and that can be reused, in many cases, reused over and over again, or in other cases, disposable. It really depends on what method you're using. But the point is, the nutrients are dissolved into the water to create a nutrient solution. And this is what is fed to plants. This is how the plants get all of their water and all of their nutrition, is from this nutrient solution. So in hydroponics, you can grow plants outdoors, like so here. This is a vertical hydroponic system. You can grow them in greenhouses. You can grow them indoors with climate control or artificial lighting. For those of you who don't have a lot of space and only really have an indoor space, hydroponics, aquaponics, great option. You're really able to pack in production with hydroponics, as you can see here, and aquaponics. Just look at how many vegetables you're able to grow in what is essentially like maybe a 6 square foot footprint. That's 40 plants right there. So you really are able to either space the plants more closely together or grow them in 3 dimensions, which is why it's so advantageous for small spaces. And then what you do is you will tightly control the water parameters, the parameters of the nutrient solution. So the pH, nutrient ratios and concentrations, the temperature, and in many cases even like the oxygen levels, and other things such as that. But those are the main ones. And so you can tailor these water parameters to whatever crops you're growing, or you can. You could just like maybe have like a nutrient solution that is designed for leafy greens in general. As we do a system here, you could have one that's designed specifically for tomatoes, even cannabis growers specifically for cannabis, specific for lettuce, specifically for whatever. And you can also adjust the composition of this nutrient solution depending on the stage the plants are in their life cycle. And this allows you to feed the plants pretty much exactly what they need when they need it, which is super cool. So here are some examples of how to actually grow plants in hydroponics. One of the most common ones is deep water culture. And this is when you have like these floating rafts that are made out of like foam insulation, pretty much the same material. And the roots are suspended in this bath of water that is aerated just by pretty much gigantic aquarium air pumps. Then you have nutrient film technique, where you have these gutters right here, and a thin film of the nutrient solution is passed along the bottom of the gutters. This is called Dutch buckets or beta buckets, where you have some kind of rooting medium, and here it's usually a solid medium, and then pretty much just like a drip line, just like drip irrigation. And then you have this drain pipe that collects the nutrient solution after it passed through the buckets and recirculates it. Another one is ebb and flow, which is where you have this table that floods periodically, and you have planting containers within the table. So you can have seed starting trays, you could have 4-inch pots, you could have even 1-gallon pots in some cases. Then you have various different kinds of vertical systems, same kind of towers. These are called zip grow towers. I really like them for aquaponics. They're pretty good for hydroponics too, especially if you're using organic nutrients as opposed to synthetic nutrients, because they have a lot of internal surface area for the microbes to grow on. And when you're using organic nutrients in hydroponics and also in aquaponics, you really want to provide lots of habitat for your microorganisms. And then aeroponics, which is what a lot of people are talking about nowadays. This is how NASA is trying to grow food in space. And here is you have a chamber that is filled with a fine mist of nutrient solution, and the roots are essentially able to grab little droplets of nutrient solution directly from the air. And this is actually the most efficient method to deliver nutrients to the plants out of all of these hydroponic growing methods. Then, of course, we have recirculating aquaculture, which is becoming all the rage nowadays. I'm sure we've all heard about some of the issues with these large-scale fish farms, the pollution they create, and all that kind of stuff. But the main thing with this is that the water is recycled, as opposed to open aquaculture, where you're diverting water from an existing watershed or existing body of water into some kind of pond where you're growing fish at a high density. This is where you have a closed tank environment, where all the water is being filtered and then recirculated back through the system. In recirculating aquaculture, the waste is managed by these filters right here. This is an example of a filter. You can see that it's filled with this filter media right here. And the waste consists mostly of ammonia and organic solids, which is basically just fish pee and fish poop. Not much to it. And then you have mechanical filters, which will clean the fish poop out of the water, the solid particles, and then biological filters, which utilize these colonies of nitrifying bacteria to oxidize the ammonia. This renders the ammonia non-toxic by converting it to nitrate. And then oxygen and water are usually returned to the system. A lot of these large-scale aquaculture systems that stock fish at very high densities actually will inject oxygen into the water. But this isn't always the case. And then, of course, the system's topped up with water. So here's just sort of like a schematic of how recirculating aquaculture works. So you have your inlet right here, and again, you have an air injector in many cases. You could also have bubblers. You don't necessarily need to inject oxygen from an oxygen tank. And as I'm sure you guys can imagine, this is very energy intensive, not very sustainable to do it this way. Bubblers are better. And other types of aerators, such as vortex aerators or spray bars, those are usually better. And then the water is circulated to a mechanical filter. The mechanical filter usually comes first because the biological filter usually can't handle very high solids loads. So and then the waste is usually diverted in recirculating aquaculture, and it's usually just disposed of. It might be dumped into a watershed. In some cases, it might be used to create some kind of product, but generally speaking, it's not utilized within the system. So this is, of course, a system with like a broken nutrient loop, because nutrients are going in the form of fish food, and then they're leaving the fish waste. So the nutrients are not being cycled through the system, or not being utilized efficiency. And the way that we can close and we're going to talk about the way that we close the gap. So that's the thing about this waste. You know, oftentimes it ends up in our watersheds and causes pollution, just like the runoff from the large industrial soil farms that are found across the Great Plains and the Midwestern regions of what is now called the United States. So this is causing many of the same problems, aquaculture. But the thing is, this waste material is extremely rich in nutrients, and it contains almost all the nutrients that plants actually need to grow. So instead of having these horrible algae blooms that are decimating fish populations across the world, why not try and grow food with it? And that's what aquaponics is all about. It's when we take the waste from an aquaculture system, and use it to run a hydroponic system. So here's a neat little video that I prepared, and here's how I would define aquaponics. It's the integration of hydroponics and aquaculture into a closed, self-sustaining ecosystem for the purpose of food and fish biomass production. So yeah, let's take a look at this video, and I can stop really quickly if there are any questions. Doesn't look like any yet, but cool visual right here. So as you can see, it is integrated into one system. Yeah, any questions? Are we good?
So is that yours right there?
That was one that I worked with when I was working for a nonprofit that no longer exists. Yes, Roman, those are goldfish. And yes, Filigree Aquatics, that is another way to utilize that waste. I'm not eating the goldfish, no. I do have tilapia in my home system, but I have not eaten them yet. I'm going to try
that, the frat party goldfish, that's where they're coming from. They're sustainably harvested.
Yeah. And there are issues with aquaponics and sustainability still, and those are very workable. It's just a matter of integrating, I guess, more ways to utilize existing waste streams into aquaponics, and there are ways to do that. We're not really going to get into that in this presentation, but I can kind of talk about it a little bit. But yeah, people don't typically eat goldfish. You can raise carp in aquaponics, and you can eat carp, but typically, if you're going to have goldfish in aquaponics, they're just a great fish for beginners, and they make good pets. So,
and they're cheap, and you can get them anywhere.
Yeah, when I used to work for that nonprofit, I would just pretty much call up pet stores and order like 100, 200, sometimes 250 goldfish from them, and just go pick them up and then introduce them to the systems. But yeah, I'm planning on eating my tilapia at some point. Haven't really gotten around to it. My system's having some problems right now, and I also have not been able to set up what's called a purge tank, which is something that you want to do before you eat your fish, just to improve the flavor. But yeah. Here it's not that cold in winter, so I'm in USDA hardiness zone 10A, which it doesn't get too cold. It gets too cold for tilapia outdoors without heating. So my tilapia system does have heating on it, but for goldfish, it's not a problem. The water might get down to like 50 degrees, maybe like 45 degrees, and goldfish don't care about that. If you live in a more northern region, then some of the so what some people do is they'll kind of let their aquaponic systems freeze over and go dormant. And if you have a very cold hardy fish, they will survive in the system. And then they will restart their systems in the spring. They'll just pretty much take all the plants out and just sort of like run the system dry and allow it to freeze over. And they might use like a pond de-icer just so that they can maintain the system properly.
Yeah, like catfish are good for that, right?
Yeah, catfish are pretty good for that too, I believe. I have raised catfish, and I think they can tolerate freezing water. I've never had any issues with catfish in cold. It's only been tilapia and cold that I've had issues with. And As far as reproduction goes, Amy, I have not seen goldfish reproduce in aquaponics. I think you can get them to reproduce in aquaponics. Tilapia definitely will reproduce in aquaponics. That is the one fish that will reproduce, and in many cases, tilapia will actually run rampant in your system and reproduce like crazy. I have a friend who had tons of fingerlings in his system, so much in fact that I could ask him for fingerlings any time of his tilapia, and fingerlings are the baby fish, and he'd be happy to give them away to me and have me take them off his hands. So if you're doing an indoor system where you're operating it at room temperature, definitely tilapia if you want to have a continuous supply of fish, and they're easy to breed in a fish breeding setup as well. But typically, if you're going to be breeding your fish on site, you're going to have a separate breeding system for that. As for clogging, yes, clogging is an issue. The mechanical filtration, if you have good mechanical filtration, is going to reduce the clogging, but you do have to service your pumps and check your plumbing for clogs regularly. Yes, Techno Hippie, I believe that has been done actually. I've seen people who run hydroponic systems off of worm castings, and I don't see why you can't integrate that into aquaponics. I have experimented with integrating compost into aquaponics. The main issue with it is that you need to find a way to deal with all the solids in the castings efficiently, and you need to be able to pretty much just extract the liquid portion from the worm castings and leave the solids behind, because the solids are generally not very usable. And I'd say the best way to do this is probably with some kind of aerobic digester. People in aquaponics use these, and they call them mineralization tanks, and they use them to deal with the fish waste. But I don't see why you can't also toss worm compost in there every now and then, and have like a bigger one that you can use for worm compost.
What this is kind of, I obviously don't know anything about this, but like, could you use something like a Jadam like microbial solution? Would that be sufficient? And then like draining off those nutrients to feed something else? Because I know that'll help accelerate that breakdown.
You typically don't use like KNF preparations in aquaponics. It actually can be harmful to the aquatic food web from what I've heard, but I'm sure that you could develop a preparation that you could specifically make for it. But I have not found actually that it's necessary to use any kind of preparation in an aerobic digester. You pretty much just need to make sure that there's constant aeration, and every now and then I'll add some molasses to it. And that's pretty much it. Like the solids in my system break down pretty well in the digester.
Cool.
But that's just fish waste. You might want to add something or like maybe add some more sugars to it if you're processing worm castings and have like a bigger digester.
Cool. All right. I'm good. If anyone else has questions.
Yeah, sure. All right, we'll keep going. Here are some pictures of aquaponic systems I've worked with. So one of the easiest crops to grow in aquaponics, especially if you have an ebb and flow system, would be watercress. Highly would recommend trying to grow watercress. You would be shocked by how quickly watercress grows in aquaponics, and it's pretty much the perfect environment for it. Again, this is a zip grow tower system. I think I have a big, more complete picture of this system later on in the presentation. I'm not sure. And then this is a media bed system that is indoors, and you can see we have a grow light. This one is actually in a middle school classroom. The nonprofit that I used to work for did these systems in schools, and it was pretty cool. The kids loved it. And you can produce like a small amount of produce in a system of this size, like decent. I would say definitely more than what you would get out of a similarly sized soil bed, even if it's indoors. So then why grow food aquaponically? So of course, you're raising fish and plants simultaneously. You are raising vegetables and you're raising fish protein, and this is very advantageous. Now, granted, you're going to be harvesting a lot more vegetables than fish, but you can still get a pretty decent fish yield, especially if you have a fairly large size system. So the other thing about aquaponics is that it's very efficient specifically because you have a complex aquatic microbiome. The thing is, of course, in soil, like as long as nutrients are being managed correctly in soil, then those nutrients will be utilized, they would be sequestered. The same thing goes for aquaponics. In an aquarium, for those of you who keep aquariums, you may know that you have to change the water every now and then because your nutrient concentrations are getting too high. You can start to have algae blooms and all those kinds of problems. But in aquaponics, because you've added the plants and you have this complex aquatic microbiome, you actually never need to change the water. I have run systems for several years without changing the water once. So that means that it's very efficient in terms of water use, even more efficient than hydroponics, because in hydroponics, you do get salt and nutrient accumulation, and you do have to change the water. And this wastewater does contribute to toxic algae blooms as well. In aquaponics, you don't have to worry about that, generally speaking. So also they're self-stabilizing and self-cleaning. And I would say in general, like for the most part, they trend towards a homeostatic state. They become self-regulating as they mature, because it's kind of like, you know, you're establishing like an ecosystem. And so as that ecosystem develops itself, as the relationships between the different organisms in that ecosystem become established, it's going to develop these feedback mechanisms that allow it to regulate itself. And that's very beneficial. The one thing is that you have to be on top of maintaining your pH in aquaponics. That's the one thing that is not as stable as the pH, because it tends to go down over time. The nitrification process lowers the pH in aquaponics, and so does mineralization. We'll talk about these two things shortly, but you just pretty much add like salts of bicarbonate. You know, you could use oyster shells, all kinds of stuff to raise the pH, and this is called buffering the pH. And it does produce small amounts of these waste biosolids still. Not all of it's going to get broken down, but what won't get broken down is great plant food, great fertilizer. I feed it to my fruit trees. They absolutely love it. Anything that you drain from your system, the effluent, is going to be great for any of your in-ground plants, just like aquarium water, except I would say even better, because the nutrient concentrations are even higher. And then, of course, unwanted organisms are kept in check by the aquatic food web. You don't have issues with mosquito larvae because the fish will eat them. Other organisms in the system will eat them. I have seen, what do I have in the system that also eats mosquito larvae? Some people keep mosquito fish in their systems, like in their filters. And I've also seen all kinds of things in there. I've seen all kinds of things. I introduced freshwater shrimp, these little freshwater shrimp-looking things called gammas to my system. They help to manage the solids. And the more biodiversity you get in aquaponics, just as you would in like a sort of regenerative farming system, the more efficiently the system will tend to operate, which is great. And over time, more organisms will make their way into the system, and the system will become more efficient. And then, of course, you end up with a system that is more efficient than RAS and hydroponics alone, because the nutrients are being better utilized. You're going to be able to utilize more of the nutrients this way. And so here's an overview of how it actually works. This is the aquaponics cycle. So, of course, first of all, we have our fish tank. You're going to feed your fish, and after they are fed, after a certain point, of course, they're going to excrete waste. And again, they're going to have solid fish waste, they're going to have fish poop, and they're going to have ammonia. The ammonia, NH3, or if the pH in your system is lower, it exists as ammonium, NH4+. You don't really have to worry about it. Just know that it's ammonia once you're getting into aquaponics as far as the basics are concerned. It'll be recirculated through the system. And so you will have some kind of filter module, and it's not displayed in this diagram. Let's pretend this is a media bed that has built-in filtration. We'll talk about why media beds have built-in filtration, why they're great later in the presentation. But the nitrifying bacteria inside will first convert the ammonia to nitrite, then to nitrate. And then this nitrate, which would normally be a waste product in recirculating aquaculture, it makes great plant food. It's a great source of nitrogen for plants. They'll take it up into their tissues, remove it from the water. Some of the other nutrients in the solid fish waste will be mineralized, which means broken down into their elemental constituents so that they exist in solution as either mineral salts or chelated metals and minerals. And then the plants can take those up. So the filters will capture the waste and clean the water and convert those waste products into plant-able nutrients. And that's what our microbiome does. That's why we want to have a solid microbiome in aquaponics. That's why we want to provide the microbiome with plenty of habitat, with adequate levels of oxygen, and just, you know, put them in the right place in the system so that they're able to process the waste products of the fish before before the water gets to the plants. That's generally how you do it. And then the plants in the hydroponic modules. So you have a hydroponic module that is attached to the fish tank after the fish will take up these nutrients, and this further cleans the water. And then after that, usually the water is returned to the fish tank and the cycle repeats. And so that's kind of like how the aquaponics cycle works. And then I also like to think of an aquaponic system in terms of its inputs and outputs, you know, because as you guys know from listening to the first episode of the podcast, we like to think of these things in terms of as complex systems, and when we're analyzing a system, we think of its inputs and its outputs and its throughput. So of course we have human labor, we have fish fingerlings. Usually when you start a system, you're going to get some baby fish or fingerlings and introduce them to the system. We have fish feed, which can exist in various forms. Many people just use like pellet or flake feed. I use the pellet feed from the Aquaponics source right now. And then nutrient supplements, because certain mineral nutrients that plants require are not present in sufficient quantities in fish waste. They're limiting. We can increase how efficiently these nutrients are made available by using like an aerobic digester, like I was talking about before. I don't really talk about that in this presentation since this is so basic, but that is something you could do to make these nutrients more available in your system. But typically we do need to supplement every once in a while anyways. And out comes produce, out comes fish protein, out comes small amounts of biosolids, and out comes green waste, which you can use in which you can put in your compost pile, use as a mulch. I honestly chop and drop all the residues from my aquaponics system at the end of each season. I don't even bother composting a lot of it. I'll compost some of it, but since aquaponic systems are so productive and they grow plants very noticeably faster than a soil garden, you're going to be able to get a lot of biomass off of a decent sized aquaponic system, and it makes a great chop and drop. I've also used the biomass from my aquaponics crops in sheet composting before. But the two things that are important to note are the ammonia and the oxygen. So you want to make sure enough oxygen is entering into your system. That's one of the most important things. You want to make sure that there's plenty of aeration. The way you incorporate oxygen is by having plenty of aeration. And then, of course, your ammonia. You want to have an ammonia balance in the system. You want to have a balance of these two compounds. These are the two major compounds that we're really worried about in aquaponics. And so here's how the nitrogen cycle works. And this is like what everybody likes to talk about in aquaponics is the nitrogen cycle. It's the main way that nitrogen is provided for in aquaponics. You will, if you're using like an organic nutrient supplement, you might be adding a very small amount of nitrogen to the system. But generally, this is how nitrogen is managed within the system. So you once again, you excrete ammonia, the fish excrete ammonia. Then you have a class of a family of bacteria called Nitrosomonas that will take the ammonia and turn it into nitrite, which is toxic. And then the nitrite is converted to nitrate by Nitrobacter and Nitrospira. And then the vegetables take up the nitrate. Then some organic waste materials are produced by the vegetables and by the fish as well. And these organic waste materials are broken down by heterotrophs, which are organisms that either consume other organisms or just waste materials in the system, as opposed to autotrophs, which photosynthesize or chemosynthesize. So our heterotrophs will consume the organic waste within the system, and also other heterotrophs. And then this is when mineralization occurs, and some more ammonia is released by mineralization as well as other nutrients. So phosphorus is released by mineralization, potassium, iron, magnesium, all those other secondary and micronutrients are released by mineralization. And then the cycle repeats. So let's talk about the basic components. So of course we have our fish tank. Think of the fish tank as the ammonia and nutrient source. Then the biological filter, our ammonia sink. This is where the ammonia becomes nitrate. And then the mechanical filter, this is our biosolid sink, which removes the fish waste. Because if we have too much fish waste in the system, it impacts water quality. Our components can get clogged. And this is what I was talking about before. Your mechanical filter is responsible for reducing the amount of solids that are present in the water. If you have too many solids, again, it's going to negatively impact water quality, which will negatively impact fish health and the health of your system overall, and encourage the development of anaerobic zones or areas in your system where there's not enough oxygen present. And this leads to all kinds of problems. It's probably the number one problem in aquaponics is anaerobic zones. Then the mechanical filter might either process these might either remove them for further processing, or might just discharge them where you can use them as fertilizer for your garden. Then you have your hydroponic module once again, and this is your primary nutrient sink. This is where your nutrients are removed. And then you can sort of see, like, we have a source and a sink. We have this balance of nutrients in our system. This is why aquaponics is so efficient. A stable aquaponic system will have very constant and very stable concentrations of all the major nutrients, pretty much. It'll fluctuate a little bit depending on which plants are growing, depending on which nutrients are limiting at the present moment, and what nutrients are in demand. Like, for example, if you have lots of fruiting crops growing, your magnesium levels might be a little bit lower. Maybe your potassium and phosphorus levels might be a little bit lower. And once the fruiting period of your crops completes, then those nutrient levels might rebound a little. But generally speaking, you want it to be pretty stable, and in an ideal world, it will be pretty stable. And in healthy systems, the nutrient levels are stable, generally speaking. And then you can also have something called a sump tank, and this is just a tank that is used to collect the water flow from all the other systems components so that the water can then be redistributed. Think of it as the sump tank is sort of like the place where you centralize and redistribute all of your system's water. And this is present in certain system designs and not present in others. It is very advantageous to have a sump tank. It can act as a fail-safe in case of a power failure because certain systems can overflow or might lose a lot of their water if they don't have a sump tank. You could end up with water loss if you're just running a system off of a fish tank only in certain situations. And it also allows you to, it's a great place to dose with supplements if you're adding supplements to your system as well. And it's also very good for, it can also allow you to run the fish tank and the hydroponic modules off of separate loops, which can be very advantageous as well because these components typically require different amounts of water flow. And so having a sump tank allows you to split the flow between the two different components so that you can run them at different flow rates. And then the pump, of course, you usually have 1 or 2 pumps in your system. I like to run a system off of 2 pumps because this allows for redundancy, and we'll talk about redundant design features later in the presentation. But the pumps, of course, will circulate the water. You might also have an air pump to provide aeration. And usually this is either housed in the fish tank or in the sump tank. So how do we culture our plants in aquaponics? These are the 6 main methods that people who practice aquaponics use. And you can see these are very similar to the hydroponics ones. So deep water culture that is primarily used in aquaponics to culture leafy greens, because deep water culture is extremely great for culturing leafy greens. Leafy greens grow very well in this kind of environment because they're small plants and they have relatively small root systems. And so you don't really need a lot of area for them to root. You can pretty much just allow them to root in like a big trough of water about 12 inches deep. And you can have them on these floating rafts, which makes it convenient to plant and harvest them. The plants pretty much just pop right in and out, makes harvesting and replanting very, very easy. And also organizing your harvest is very, very easy. The other advantage of deep water culture is that because you're growing plants in a very large volume of water, there's lots of thermal mass in your system, and this stabilizes the water temperature, and which is very important in aquaponics. Because an aquaponic system is really an ecosystem, it is constructed ecology, you want to maintain relatively stable conditions within that ecosystem, because this will reduce the amount of stress that ecosystem has to endure. So deep water culture is very advantageous for that reason, and it is the primary way in which leafy greens are grown commercially in aquaponics. Vertical towers are advantageous because they allow you to really pack it in. They're the ideal type of aquaponics system or system that you would use in aquaponics for growing your plants if you're working with a very small space, because again, it allows you to grow in 3 dimensions. It's not going to be as productive. It's not going to allow for a system that is as productive and stable as deep water culture if you're growing leafy greens, but vertical also allow you with a bit more flexibility. I would say that strawberries generally tend to do better in vertical towers than in deep water culture because strawberries are very susceptible to crown rot, and in deep water culture, the crowns of the plants might end up being a little bit more moist than they would be in vertical towers. The other advantage to vertical towers, and especially these guys in particular, the zip grow towers, is that you can fill them with media, and this media can also act as a biological and mechanical filter as well as a rooting medium for the plants. And so this will allow you to potentially reduce the size of the filtration that you have on the system, and allows you to, again, sort of pack in your system and allow it to be more compact and suited for a smaller space. And then we have a media bed, and you can have multiple growing methods for one system, especially if you're growing on a small scale for home production. As you can see, this is the same system. This is my home system. It has towers and a media bed and an ebb and flow table. So we have 3 growing methods in one system. and this is something that you can do. But if you're growing like on a large scale and you're producing like just like a single crop, then you're probably going to only have one growing method, so you can optimize the water chemistry for that crop, because that is something you can do in aquaponics as well. You're generally less precise with it in aquaponics as you are in hydroponics, but it's advantageous and it'll allow you to optimize your yields. So for media bed and ebb and flow table are very similar conceptually. So you have a trough or table where the water level fluctuates. It either fluctuates or it floods periodically. So for media bed, the water level is going to fluctuate on a 5 to 15 minute cycle, generally speaking. And so the water level in the media bed will raise up to about 1 inch below the surface of the media, and then a siphon will initiate, pull all the water out of the bed, or most of the water out of the bed, until there's only about 1 inch of water left, and then the siphon will reset and the cycle repeats. And so as the media bed fills up, the plants are being given access to water and nutrients, and as the media bed drains, air is sucked into the system, and then the root systems of the plants are oxygenated. And media beds are able to grow plants extremely rapidly for this purpose, for this exact reason, because it provides an environment where plants are exposed to ample amounts of nutrients, water, and oxygen from the atmosphere. The other advantage to a media bed is because you're working with a media that has a lot of surface area, it is able to both capture solids and host nitrifying bacteria. So you can actually design a very simple system with just a media bed and no additional filtration. This is the type of system that we're going to be talking about how to design in this presentation and build in this presentation. So probably the best method for beginners is a media bed. They're very forgiving. The main drawback to them is that when you do have to clean the media, it's a lot of work. I would set aside an entire afternoon to clean a media bed, even a small media bed of this size. You have to pretty much remove all the media, wash it, and then put it back in. So it's a bit of a pain to maintain it, but you generally only have to do this every 6 months to 2 years. Then, of course, nutrient film technique, once again. This is used in aquaponics. The trouble with nutrient film technique in aquaponics is that you have to have a lot of filtration for nutrient film technique, because the emitters that spray water into the gutters in nutrient film technique tend to go very easily. So you have to make sure you have very good filtration. Same for the beta buckets. You want to make sure you have good filtration. But this is going to be your best bet for a lot of your fruiting crops. And then, of course, ebb and flow, as I talked about. This table is run off of a timer that floods the table for 15 minutes twice per day. And this is what I use for my seedlings. Ebb and flow is great for seedlings or for plants that are in containers. I would say in aquaponics, mainly for seedlings. If you're growing in ebb and flow with larger containers in aquaponics, then you tend to get issues with the rooting medium becoming anaerobic very frequently. And this is not great. This will impact the health of your plants. But if you're just doing seedlings, this works really, really well for seedlings. And then sort of like, here's a table of the different growing methods and what you can really grow. And you can see root crops are one of the things that you can't really grow in aquaponics. I mean, you can, but it's difficult to do and you might not get great results. I have seen people grow sweet potatoes in a media bed, for example, and get a pretty good yield. But in many cases, if you're trying to grow a root crop, then the tubers or the roots will end up small and or deformed. So it's not the best option. But you can see like these are kind of your options here. I think this is a good place to stop for questions. That NFT. So right here, the term NFT, like people are talking about this NFT bullshit nowadays, and I'm just like, nutrient film technique. I wish that's what they were talking about.
Yeah, I mean, that's something worth stealing. So yeah, I think this makes a lot of sense. The only anything similar to this hydroponics I've ever done is Kratky, which is like very, very stripped down basic. I'm sure you're familiar with it.
Yes, I am.
But that's why I did it, because it's like, oh, you can grow lettuce in a mason jar in the winter. Okay, I'll try that. So for people that aren't familiar with Kratky jars, they're literally mason jars or whatever container you want to use. You add your nutrients to the water and you put a little something so that your plant doesn't sink into the water, and you let it grow and you don't do anything. It's the best kind of planting.
Yeah, and it's sort of like same idea in deep water culture. Like all Kratky is deep water culture without oxygenation. That's all that it is. And usually in the rafts, you'll have those net cups. You'll use the net cups as well in those rafts. So question. Adrian V asked, the smallest setup you could have with the system indoors, what species might be good for that? So if you want to have a serious indoor system, I would say 50 gallons minimum. I've worked with 20-gallon systems. I've worked with 5-gallon systems. They're pretty much only for display purposes or as a conversation piece. You're not going to really get much yield out of them. Once you get 50 gallons and above, then you're starting to be in business, I would say. And a 50-gallon system, I would say that's probably about a 12 square foot footprint. So it's not terribly large. That's something that you can put in your den or in your kitchen or wherever. As far as species of fish go, I would say the two for a 50-gallon system that you'd want to use would be either goldfish or fish in the sunfish family. So bluegill especially. I would say bluegill is probably your best bet for that because they're small. They can do well in relatively tiny tanks. Tilapia are very, very marginal at that size. You might be able to do like a tilapia or two in there, but good luck. It's just probably just not worthwhile to do it. And tilapia in less than 100 gallons. I'm running tilapia. I've run tilapia in a 90-gallon system, and you can only really have like 8 to 10 fish in there. It's generally not worth it. I would say goldfish or bluegill for a small system.
And a question for you. When we talk about buying like bluegill and catfish, stuff that like PetSmart isn't going to have, where do you get those types of fish?
I would look and see if you could find a good professional aquaculture list that stocks them, and I would buy them as fingerlings. I have bought tilapia from Lakeway Tilapia before, and I'm of course I'm not advertising anybody, but I really did like their tilapia. I have not bought bluegill before, but I know for those of you who are in California, there is a company based out of Fresno called J&J Aqua Farms that does have bluegill and a bunch of other fish. And there are tons of other aquaculture suppliers. So just like search bluegill fingerlings on Google or whatever search engine you use, and you'll probably find some aquaculture supplier. Just look at their reviews, make sure that they supply to like professional fish farming and stuff. But yeah, can you catch wild fish for use in aquaponics? I would not recommend it. They would probably introduce diseases. Try it. You know, my philosophy is try it. You know, like why not? But just keep in mind that you could either be introducing fish diseases into your system at concentrations that are higher than you would want them, because you're always going to have diseases no matter what. You know, if you're bringing in any fish in your system, there's going to be diseases because they're microbes and they're present everywhere. But I just don't think wild fish would do very well in aquaponics. Just like taking a fish and bringing it into a tank environment, it's a big change, especially if that fish isn't going to be very well suited to a tank environment to begin with. So yeah, probably not the best idea, but try it. But cost. So yeah, we're going to talk about what to get secondhand for aquaponics systems, and that'll be talked about later in the presentation. But I will say for now, the only thing that you really have to buy new is pumps. You can even use old plumbing. And I would buy a new pump, but you don't have to. But like if you're using like a cheap pump, you're trying to cheap out on your system, get it new for sure. Because unless you're going to invest in like a very high quality used pump, then you're going to want to buy a new pump. A lot of the pumps will fail pretty quickly, the lower quality ones. How much did you spend to get started? So the starting budget I have for like a decent aquaponics system is $1,000 USD. You could probably go less, but like I would say if you want to be serious about this, set a KSI. And we'll do a breakdown. I have a cost breakdown of a simple system later in the presentation, and we'll go over that. Stocking permits? No, I've never had that issue. I mean, I'm of course in suburbia, so I don't think anybody cares as long as you're not stocking illegal fish. The tilapia that I have are Mozambique tilapia, and they're the only ones that you can stock here without a permit. But even then, like, you probably won't get hassled if you're in a suburban environment. If you have a larger scale operation and you're stocking like fish without a permit, then yeah, I'm sure you'll get hassled. But yeah, when it comes to goldfish, I like to get just the comet feeder goldfish because they're a dime a dozen. So, but I would expect very high mortality rates if you're buying goldfish from a pet store. at least 10% and up to 80 or 90%. And there are ways to introduce fish to a system properly. I did a video on my YouTube channel on how to transfer fish from one system to another, but I haven't done one on how to introduce fish, but the procedure is very similar. Yeah, anyways, any more questions that we can continue? Oh yeah, and feel free to take screenshots, by the way, and of course this will be up and recorded later, so yeah. All right, let's get going. We're ready. So here it is. This is the chop and flip system. This is what I think that you should build if you're going to go ahead and spend $1,000 building an aquaponics system. It's very easy to maintain, very simple, and you can grow pretty much any vegetable in it. So all it is it's a media bed system with a single pump and a fish tank. And chop and flip, chop stands constant height, one pump, and the flip refers to the fact that you're just like flipping over the top of an IBC tote into a media bed. That's it. You cut off the top and flip it over and make an IBC tote and set it on top. Very, very simple. So yeah, we're talking a media bed system with a single pump and fish tank. It's a simple design that can be built cheaply with secondhand items, and cheaply, relatively speaking. On my system, I probably put about $2,000 into my system, the tower system that I showed you guys before, at least. And I even got some parts secondhand for that for free that were given to me. So it can get expensive if you're building a more intricate system. And also, it's a fairly reliable system. Your only real point of failure in the system is the pump. So as long as you have a good pump and a battery backup, you're good to go. And then, of course, it is large enough to stock edible fish. This one would be great for tilapia. It would be great for bluegill. It would be great. I would not do catfish in this system. That's the one thing that the system would not be able to handle is catfish. It's not that the tank is too small, but it's that catfish do not like the vibrations that pumps create. So you need to have your pump housed in a sump tank in order to raise catfish. It stresses them out. But it's great for pretty much anything else that is edible and that does not get too large. I've even heard of people attempting trout in these systems. And then, of course, yeah, it grows a wide variety of crops, and you can upgrade the system relatively easily. If you wanted to add a sump onto this, you could. If you wanted to add filters onto this, you could. If you wanted to add more grow modules, you could. Like a 200-gallon fish tank can accommodate a pretty large growing area. And you can even add more fish tanks. So it's pretty modular, pretty upgradable. So it's a great place to start. So here's a basic overview of how it works. So of course, our water is moving in a closed loop. We have a pump down here that pumps the water up through this delivery pipe into the bed. And the water just pretty much flows directly into the bed. Oftentimes, people will install a spray bar to distribute it more evenly to oxygenate the water better. What I like to do is oversize the pump and have a relief valve that is teed off here and have water flowing out of that constantly, because that'll aerate the fish tank more, especially if you create vortex flow within the fish tank. It's a great thing to do. So pretty much just install a T right here, then a valve, and then an outlet to direct water flow in a somewhat circular motion. That'll also allow you to control the flow rate to the bed. But you can also just install a ball valve directly on the delivery pipe and not do that. But then in the middle of the media bed or on the side, it's either usually on the middle or off to one corner, you'll have this siphon. And the type of siphon that is typically used is a bell siphon. I'm not going to get exactly into how a bell siphon works in this presentation. There's just so much to cover with aquaponics, and I don't want to take up everybody's entire day, because I could talk about aquaponics for hours and hours and hours and hours, and I don't want to do that. So all you need to know about a bell siphon is that it causes the bed to flood and drain over and over again automatically by employing a siphon. So the bed will fill up. That'll cause the siphon to initiate. Then the siphon will drain the water out of the bed. And then when the water level gets to the very bottom, the siphon will allow air in. The siphon will break, and then the cycle will restart. And typically, with an automatic bell siphon, the flooding and draining of the bed will be on a 5 to 15-minute cycle. I've seen it go as high as an hour for a very large media bed, but 5 to 15 minutes is pretty good, generally speaking. The rule of thumb in aquaponics is that you want your pump to be able to move water equal to twice the volume of the fish tank each hour. So I did not mention that like in the slides right here, so I would write that down. twice the volume of the fish tank per hour. So if you have a 200-gallon fish tank right here, you're going to want to move 400 gallons per hour through the media bed. And then here's a simplified parts list for your chop and flip system. Yeah, use a secondhand IBC tank. Make sure that it did not contain something that is toxic to fish. And I have a story to tell you guys. So this is this system right here. Let me see. This system right here. So this was an aquaponics system where the fish tank was an IBC tank. And unbeknownst to us, the IBC tank was used to store vape juice. And so it was contaminated with nicotine. And so whenever we tried to stock the system with fish, they would pretty much just straight up die. And the nicotine became impregnated into the plastic, and we couldn't get it out even after washing it multiple times. And we had to scrap the entire IBC and all of the components of the system that came into contact with it and reinstall them all over again. It was a huge hassle. And it really sucked because literally like 9 months later, a large tree fell on the system and completely destroyed it. But yeah, so make sure you vet your supplier when it comes to buying secondhand items. That's very, very important. Do not get items from a supplier that you don't trust or that you think may have been used to store something that could have potentially contaminated the plastic or may be toxic to aquatic organisms. Oftentimes when I buy an IBC tank that's food grade, it'll have been used to store like fruit juice or soybean oil or syrup, like fruit juice, vegetable oil, syrup. Those are all fine as long as you wash it out thoroughly. If you're going to wash out your secondhand parts prior to use, now I would wash out anything prior to use, even new parts. Wash it out and use Castile soap. I use the Dr. Bronner's unscented. Unscented Castile soap is what I like to use. So yeah, make sure to wash it out and vet your components. So and then for the pump, I put this Danner Pondmaster 5 pump here. This is a 400 gallon per hour pump. And again, not advertising a product, but this is probably the favorite of the brands that I've used. They're not cheap. You can get a 400 gallon per hour pump for about a third of this price, but this will last you 3 to 5 years as opposed to 6 months to 1 year. So if you want to get a good pump, get something like a Danner pump. And there are plenty of good brands out there. Just anything that's very well built. And what these are is they're submersible mag drive pumps. And so basically on the inside of the pump, you'll have a drive shaft, and then inside of the drive shaft sits this impeller. And so basically you have a magnetized cylinder with like an impeller attached to it. And then when you turn on the pump, a magnetic field is induced within the drive shaft, and that causes the whole impeller assembly to spin around, and that moves the water. So that's how that works. If you take apart one of these pumps, you'll see exactly how it works. It's pretty simple. You can get these anywhere. Of course, you don't have to get them from Amazon. You can find them on Amazon. You can find them at a pond supplier. Go to your local pond supplier store. They'll have them. Yeah, 400 gallons per hour is good for a chop and flip system. Then your bell siphon, you can totally DIY a bell siphon. So if you look at Rob Bob's on YouTube, he's probably one of the biggest aquaponic channels on YouTube. He has a bell siphon tutorial. Check that out if you want to DIY it. And you can also buy a kit from the aquaponics source after shipping and stuff. It's probably going to cost you about $45 to $50. You could definitely do it for cheaper than that. You could probably make a bell siphon for $20. I kind of just pulled these numbers out of my ass based on my experience. And then just PVC for plumbing. And as you can see, the plumbing is very simple. You just have this delivery tube right here. And again, I would install the T with the relief valve on here. Then you have just the outlet pretty much. So that's all it is for the plumbing. And this is definitely an overestimate. It's not going to be expensive at all for the plumbing. And the thing that's really expensive is going to be your media. And so for this, I put Hydrotin. I like to use the Hydrotin. That's just what I'm used to using. Probably not the most sustainable thing. It's not horrible, but the issue is that the supply is kind of running out of it right now. It's probably going to be a bit hard to find. So I would use lava rock instead if you can get a hold of lava rock. And the other benefit of lava rock is that it's going to slowly release iron into your system, which will supplement your plants with iron, which is pretty great. And so this is what you could expect to pay in parts. I would say, depending on where you live and how much you want to spend on a pump, anywhere from $550 to $700 is what you're looking to spend on the system itself. But keep in mind, you're also going to want to spend money on fish food, your test equipment, your supplements, all of your plants, like a setup to start seeds, all that kind of stuff. So just to be safe, I would budget $1,000 to start your system if you're doing a chop and flip. And this is what I'd start with because easiest system. But there are more advanced designs. So this is an example of a more advanced deep water culture system. Deep water culture, again, is great for leafy greens. And you can see you're running this much growing area off of one 275-gallon fish tank. And these are filters right here. These are those blue high-density polyethylene food-grade plastic 55-gallon drums. And you can easily get those off of Craigslist or wherever. And here's a sort of like the schematic. This is a pretty simple system as well. So in this case, this one does not have a sump tank, but it's very similar. You pretty much just add in a sump tank. So your water starts at your sump tank, and you split flow between your DWC rafts and your fish tank. And then the water is filtered after the fish tank where it returns to the sump. And so then you're pumping filtered water, filtered fish tank water into your DWC rafts. As far as the filters go, your radial flow filter is a type of mechanical filter that is very efficient, and your MBBR or moving bed bioreactor is a very efficient self-cleaning biological filter. And I swear by these things. I love my MBBR on my system. It's fantastic. I have to clean it about once every 6 months to a year, but it's fairly easy to clean and it's very efficient. It's a very compact device and it's quite reliable. The only drawback is that you need an air pump to run it. But that's not that big of a deal because if you oversize your air pump, you can route some of the air to your fish tank to help aerate the water for your fish. But yeah, MBBRs, you generally need 1.5 times less area for the bacteria to live on than a conventional, just like static biofilter, which is great. It's just like a static filter that's just filled with some kind of media. And you can use all kinds of things. You could use bottle caps for your media. You could use like regular pond filter media. You can use whatever, like as long as it's something that is food safe is what I would say. Food safe plastic is your best bet, like food safe polyethylene, something like polyethylene is very typically used. The HDPE is very typically used in the systems. And also PETE, which is used in water bottles, is fine too. It's a great way to reuse our plastic, that's for sure. Yeah, here's my system at my house. So you can see towers, media bed, ebb and flow table for the seedlings, fish tank, sump tank. And so the water is pumped up from the sump tank. One loop goes into the towers. And I recently reconfigured the plumbing so that the excess water, instead of going to the media bed from the towers, just goes right back into the fish tank. And then I have off of the tower line, I have it teeing off into the media bed. But you'll see in the schematic, it's the old setup. But I find teeing it off directly into the media bed is better. It gives me more control. So yeah, that's one loop. Towers drain into the fish tank, and the excess flow from the towers goes into the fish tank and back to the sump tank. And then the other loop is another pump runs the filters, which go to the fish tank and back to the sump tank. And then, of course, the media bed also goes back into the sump tank. And so this is a system with redundant design features. Since we have two pumps, if one of them fails, there will be water running through the fish tank no matter what. Fish in an aquaponics system cannot survive very long without water flow. I would say in a system that is stocked at your typical stocking rate for aquaponics, which in imperial or American, I guess, is 1 pound of fish biomass per 10 gallons of water, after about 24 hours, your fish are probably going to be done. They're dead without water flow. So if you have two pumps pushing water through your system, then you're going to have redundancy. Because if one pump gets clogged, if the impeller in one pump breaks, or if the drive shaft gets warped and the pump can no longer run in one of them, because these are all things that happen to pumps over time, then you still have your other pump to pick up the slack. And the other great thing about this system is since the towers and the media bed also provide some filtration, then they're on one pump and the dedicated filtration is on another pump, then no matter what, you're also getting filtration. So, and this is great, if I need to go on a trip, if I don't pay that much attention to my system, I know that since my system has this redundant pump configuration, it can pretty much take care of itself. And so, yeah, again, this is a hybrid system that is suited for growing a wide variety of crops at your house, on your home, wherever, in your community garden, wherever you want to do it. And on a small scale. So yeah, some guidelines for building your system. I would say, and I do post memes on my Instagram too, sometimes about aquaponics, so check out my Instagram. Construct on a flat and level surface. Unless you really know what you're doing, you do not want to build an aquaponics system on a slope or an incline, because you want to make sure that all of the water in all of your components is level. If you don't have level water in your components, then you can get water pooling somewhere. This can create an anaerobic zone. This could interfere with proper water flow within your system, and it's just not desirable. So I would say the easiest kind of foundation to construct is a gravel foundation. You could also just level out the soil and put your system on like wooden pallets, depending on how large it is, or you can even pour down some concrete, whatever you want to do. I would say, of course, if you're designing a large system, concrete might be a great option, but you don't have to use concrete. Then, of course, only food-grade components. If it's safe to put in our bodies, for the most part, it's safe to, I mean, relatively safe. You know, how safe food-grade plastic is totally arguable, but, you know, it's safe enough for fish is what I'm trying to say. And again, vet your sources if using secondhand components. As for plumbing, I like Schedule 40 PVC. If you're able to find a plant-based material like bamboo that works well for you, go plant-based. I'm always in favor of using biological materials as opposed to plastic. That's one of the problems with aquaponics, is that it's still very reliant on plastic. But Schedule 40 PVC works well, and polyethylene irrigation tubing works well. Those are pretty much the only two things that I use: Schedule 40 PVC and polyethylene irrigation tubing. So that means no ABS. ABS is not food safe, so it's not aquaponics safe. And don't use metal plumbing components either. The only thing in your system that should be metal is whatever's in your pump. You want to minimize the amount of metal that is in contact with the water. And that's because many metals are very toxic to fish in low concentrations, especially zinc and especially copper, and especially the heavy metals that are also toxic to us. And if you have like galvanized steel tubing in your system, or like copper tubing, that's going to poison your fish over time. So just don't use it. As for your media, the ones that seem to be the most reliable are the LECA, the expanded clay balls that I talked about earlier. And again, supply of that is short. It's like a specific type of clay that comes out of this one mine in Germany. And it seems like the mine is almost exhausted, so it's not really being made anymore. But lava rock works well too. Just make sure that you follow proper cleaning procedure for this media. You always want to pre-wash it before introducing it to your system. And I'm not sure if there are special procedures for lava rock, but there might be. Look into that. I have a friend who swears by lava rock and loves it, but I'm not sure exactly what goes into prepping lava rock for your system. So be sure to look into it. I've never used it myself, but I hear it's great. And if you're using any kinds of fittings, the most typical fitting you'd use for aquaponics is called a bulkhead fitting. And this is what is used in like large aquariums. So you can see the junction right here, down here where the bell siphon joins with the bottom of the media bed is going to be where you're going to have one of these bulkhead fittings. It really pays to seal it up with silicone so it doesn't leak. You do not want a leaky system because leaks in aquaponics are very hard to deal with. You pretty much have to drain out your entire system or isolate the component that is leaking in order to fix it, and it's just not something you want to deal with. And then again, when it comes to leaks, make sure you test your system before starting it, before adding all the water, before fishless cycling your system, before introducing fish and plants. Make sure that it's leak-free first. And then other components you can easily get secondhand. Glass aquariums totally work, especially if you're using an indoor system. Nothing wrong with glass aquariums. The one thing I would say is that circular fish tanks allow for more efficient water flow. If you can opt for a circular fish tank in the future when you're doing a large system, go for it. Also, these large water tanks that are commonly used on farms and ranches, great, go for it. 55-gallon blue plastic drums, go for it. Those are awesome. These make great housings for filters. My swirl filter, which is another type of solids filter, mechanical filter, I made out of one of these. And then, of course, pallets. You can use this as siding for your system. You can use it as a support, whatever. You could use it to build the structure, whatever you want to use it for. But yeah, so we're going to talk about fish next. So if you want to take questions, now is a good time. Yeah, I know it was hilarious that it was vape juice. I was just like, man, we get it, you vape.
Yeah, I don't know if someone else has a question.
Oh, PVC, yeah. So PVC pipe, the Schedule 40 stuff, use that. That's fine. the thing that happens with the plumbing and all the components of the system that contact water actually is that over time a biofilm of microbes will begin to coat them. And so like if there's anything in there that's not that great, like especially in PVC, then it usually won't be a problem long term. Yes, an aquaponics system can be incorporated into an existing pond. And what you're going to want to do is, one, increase the stocking density of your pond to whatever your pond can handle, and two, install additional filtration because you want to make sure you have good mechanical filtration and good biofiltration. Once you can get your filtration right and your stocking rate right, then we're good to go. It's definitely been done. Oh, PEX, yeah. So anything that's not UV stable, don't use it, especially outdoors. Can the water be made potable? I've never attempted that. I would not drink it. I mean, it's not going to be super dangerous, but I have heard of, I do know that salmonella can survive in aquaponic systems. Giardia can survive in aquaponic systems, so I would not drink it. I've definitely swallowed some accidentally. I definitely put my mouth up to the pipes to blow solids out of them all the time. I've never gotten sick from contacting aquaponic water, but I wouldn't drink it. If you want to try making it potable, then I wouldn't know exactly what to do, except maybe like running it through like some kind of flocculation. I don't know. We're going to talk about fish and plants next, and system maintenance.
Cool. I'm looking forward to it.
Yeah, is everything been pretty clear so far, guys? I know I'm kind of blazing through this. There's a lot of material to cover. I don't want to overwhelm you guys. People oftentimes get overwhelmed when they are new to aquaponics. It can be overwhelming, but you'll get the hang of it, and you'll understand it in time. So common fish in aquaponics, already talked about tilapia, catfish as well. Channel catfish are most commonly used. Anything in the carp family. So that's common carp, that's koi, that's whatever kind of goldfish you want to put in your system. Those work great. Great for beginners. Very forgiving. Sunfish family, so sunfish, bluegill, crappie, those are great as well. Various kinds of perch. The Australian aquaponic people love to use perch in their systems, and also barramundi. Barramundi is an Australian native fish that a lot of the Australians also use, and then trout for cold water aquaponics. So here's a table going over sort of the fish and their requirements. So tilapia are your warm water fish. So, and they are the hardiest fish you will find, except when it comes to cold water. They are wimps when it comes to cold. So I would say, unless you live in a subtropical climate or you're doing your system outdoors, tilapia are just not worth it. And even in my climate, in USDA Zone 10A, I need to have heating in the winter or they will die. And it takes a lot of energy to heat an aquaponic system. For a 300-gallon system, 200, 300 gallons, I'd say 800 to 1,000 watts. Like, that's a lot of power. It's not sustainable. And I'm thinking of getting rid of my tilapia for that reason, because it's just, not great. And, granted, my house is on solar, so it's not that bad. One can argue, but it's not the best thing. So unless you're in a very warm climate or doing it indoors, tilapia are not the best idea. But if you are in a place where they can do tilapia, without having to invest all this energy into heating, they grow so fast, they tolerate shitty water, and they are so forgiving in general. And they breed like crazy. They reproduce like crazy, which is awesome. So you're never going to run out of fish if you have tilapia. Catfish. So if you live in a temperate climate, great alternative to tilapia, except they take a lot longer to reach plate size. And plate size is just your size at which you would, harvest the fish to eat them, like at a minimum, like your minimum size. Typically, it's for tilapia, it's 500 grams. For catfish, I think it's 1.5 pounds or like 18 inches long. It varies depending on the fish. But catfish are also fairly tolerant of poor water quality. Not as tolerant as tilapia in my experience, and not quite as tolerant as goldfish. They will not eat if water quality is too poor, but they are pretty tolerant overall. They also require sinking food. That's important to note with catfish because they are bottom dwellers. And the fact that they are bottom dwellers means that they pair well with other fish that occupy the upper layers of the tank. So that occupy shallower water. So you could culture catfish with bluegill, for example. and they would coexist pretty well together. Or catfish with tilapia. The main thing is if you're going to culture more than one species of fish together, introduce them at the same time and as fingerlings. Otherwise, they will fight and they will eat each other. Carp family fish. So very wide temperature range. They're happiest at 25 to 27 C, so like 74 to 78 Fahrenheit. That's where they're happiest. But they'll be happy all the way down to freezing, and they'll be happy all the way up to, I'd say, 85 degrees, relatively speaking, as long as they're mature fish and they're well established in the system. In my experience, they don't handle heat quite as well, especially goldfish, but they do handle it. Catfish definitely handle heat a lot better, and tilapia really can handle heat. In fact, the Mozambique tilapia, the kind that I stock, can handle 103-degree water. So sunfish family fish, again, they can handle heat pretty well too. They sort of like it a little bit on the cooler side, but they're very adaptable and they will do great, in a very wide range. And again, they're great for small systems too. I would say if you don't want to do goldfish and you want to eat the fish that you're going to be raising, and tilapia don't make sense in your situation, start with bluegill. That's a great place to start. Perch is kind of like tilapia, don't tolerate cold water, but a lot of people like to eat perch, so they will raise perch, and they're great commercial fish. And then trout are sort of like the canary in the coal mine of aquaponics. They require cold water and really, really, really clean water. But if you are able to provide this to trout, then they will grow faster than tilapia, and they'll do fantastic. They're very vigorous fish, and they also require a high protein feed because they're carnivores. But this is your general overview of sort of like the common fish in aquaponics. Calculating stocking and feeding rates. Fish should be stocked at a rate of 10 to 20 kilos per 100 liters of water for 1,000 liters of water. Sorry, for adult fish. Excuse me. So your ideal feeding rates are calculated using dimensional analysis. So if you've ever taken college level chemistry, then you've definitely done this before. And it's math. So in aquaponics, when you're designing your system and you're calculating your feeding rates and your stocking rates, you're going to need to do some math. It's just inevitable. So this is how you do it. It's pretty much just conversion factors that dimensional analysis is. So you start out with 25 kilos of fish in your tank, for example, and you multiply it by the feeding rate. You want to make sure that your units cancel out. And then you might want to convert that to grams to make it easier to measure, like if you have a scale. And this is going to be your idealized feeding rate per day for 25 kilos of fish. This is how it's calculated in commercial aquaculture. And for fry, they might require a different kind of food. They usually do. They usually require high protein feed. You use the same formula essentially. But yeah, so your stocking rate is going to be 10 to 20 kilos per 1,000 liters. And this works out to round about 1 pound per 10 gallons of fish, give or take a couple pounds. One pound of fish per 10 gallons of water, give or take a couple pounds. I would not go higher than 20. And that's if you have really good filtration and a cylindrical tank. In like one of these chop and flip them with the IBC tank and the media bed, I would stick with 1 pound of fish per 10 gallons of water. 1 pound of fish per 10 gallons of water, not 10, I'm sorry. So starting up your system, so you can't just throw fish into your system. It just doesn't work that way. That's a great way for people to get discouraged, is for them to build their system, for them to buy fingerlings, spend all this money, introduce them, and then have them die. Because there's no microbiome established. You have to establish your microbiome before you can introduce fish. So the process of establishing this microbiome is called fishless cycling. And if you've ever had an aquarium, you'll know about this. So the easiest way to do it is to introduce an inoculum of nitrifying bacteria. If you have an outdoor system, I do not recommend using those store-bought aquarium starters. Not a good idea. Those bacteria are not adapted to an outdoor environment. What I would do is find a friend with an aquaponics system, take a gallon or two of their water and dump it in your system when you're starting it, and the bacteria will come over. So make sure your pH is between 7.2 and 7.8, because this is the pH that the nitrifying bacteria like. As your system matures, they'll be able to tolerate a lower pH. and then raise your ammonia concentrations to 3 to 4 parts per million. You do not want it any higher, because higher than 4 parts per million becomes toxic to the nitrifying bacteria. Then you can see as the cycling process progresses, and this is if you're using fish food. If you're using just straight ammonia, it's going to start up here, obviously. Your ammonia levels are going to peak, then your nitrite levels are going to peak, and then your nitrite is going to zero out, and you're going to start seeing nitrates. When your ammonia and nitrite zero out, that's when your system is cycled. Then you can introduce fish. So when you have fish in your system, it's established, you're maintaining it, because once you get fish in, you can introduce plants. And you need to introduce plants relatively slowly. You only want to introduce plants that can handle, or I would say you would only want to introduce so much plants that the system can currently support with the amount of food that you're feeding the fish. So the amount that you want to feed is roughly what they will eat in 10 minutes. And you want to try and get this as close to your ideal feeding rate, given how much fish you have in your system, as possible. That'll allow your system to operate the most efficiently and yield the most produce. So when you're topping off your system, use dechlorinated water and top off once the water level falls below 80%. The reason why you want to do this is because a large change in the water's and the volume of your system's water in a short time period will throw off the system's water chemistry, and this is stressful to the fish. So once you get below 80%, just top it off. You can also have a reverse osmosis filter with a float valve on it. I also like to do that to top off your system automatically. It's totally easy to automate your system. And also, do not allow the pH to change by more than 0.2 per day. This is your rule of thumb for pH changes, because fish do not like sudden changes in temperature, pH, or water chemistry in general. It stresses them out. It's a very easy way to cause them to get diseases and die. So make sure to keep the pH relatively stable. I would say test the water at least once per week. The main thing you're going to want to be on top of is pH and nitrate levels. Also test for ammonia and nitrite, just to make sure that there's not a problem. Then supplement every 3 weeks or as needed. So we'll talk about supplementing at the end of the presentation. And also maintain a supply of seedlings for transplant. You can go to the nursery and buy starts and put them in your system. You can totally do that, but I find that it's easier and more convenient and better to start your seedlings on site in an ebb and flow table that's attached to your system. Very easy to do. Also, clean your system regularly. So when it comes to cleaning, depending on the type of filter that you have, I would say mechanical filters need to be cleaned depending on what kind it is. If it's like a settling type filter, once a week. You'll want to drain off the solids once a week. Ideally, once per day if you have a mineralization tank like I do. You'll want to do it once every day or two. But max once per week, drain off those solids so they don't begin accumulate and going anaerobic. Because when a part of your system goes anaerobic, it begins to produce compounds that are toxic to the fish. You don't want that. So when it comes to like a static media filter, like for example, just like a big box or like drum that's stuffed with filter media, every couple months clean it. When it comes to a media bed, clean it every 6 months to 2 years, depending on the media bed. See how much your media bed needs to be cleaned. I have seen systems go for several years without cleaning. And there's another one that I work with right now that has to be cleaned every 6 months. So just get a feel for it. And, I would start with 1 year, every year. And how frequently you're going to have to clean your media bed is going to depend wholly on how good your filtration is. So if you have additional filtration on your system, you're going to have to clean your media bed less. Also, regularly check for clogs and wear and tear, and only control pests with fish-safe agents and techniques. We'll talk about that, and be prepared to deal with the occasional fish deaths and diseases. So given that an aquaponics system is a complex system, when you have a stressor, when you have a catastrophic event, you run the risk of destabilizing the system and causing a feedback, causing a snowball effect that then causes the system to crash. So if there's a problem, you need to be on top of it. That's the thing in aquaponics. Aquaponics systems require way more observation and monitoring than they do labor, because it's really not a lot of work to maintain the aquaponics system. Most of the work that you're going to be doing is just harvesting and transplanting your plants, which is pretty easy in aquaponics. It's definitely less time consuming than in soil, and just feeding your fish. You're not going to need to do much more than that. But you need to make sure that your system is healthy, because if it's not, and something is out of whack, then the entire system could crash. You could lose all of your fish, and then you'll be SOL. And you'll have to introduce fish all over again, get your water chemistry right all over again, and reintroduce plants. And this process can take several months. And you don't want to have to deal with that. So, and then, yeah, all things considered, an established aquaponics system requires minimal labor. So I'd say my system at my home, if I were maintaining it well, 30 minutes to an hour a week for that guy. For one that's a bit larger, maybe a couple hours a week. And most of that is going to be harvesting and transplanting. Keep that in mind. It takes 5 minutes to feed the fish, you know, and it's going to take 5 minutes to feed the fish, whether your system is small or large. And at that point, you know, you're just really worried about harvesting and transplanting and making sure that your system is producing. And that's really all that the labor is making sure that the system is productive and putting out vegetables for you to eat. So now let's talk about water parameters. Before we get into this, are there any questions? So yeah, I'll go back. Adrian asked, are snails beneficial? Depends on the type of snail. So I have these little tiny snails in my system. I think they're not cone snails, but they're like little tiny pond snails, and they are beneficial because they eat algae and they prevent too much algae from accumulating in the areas of your system that don't have fish. So yeah, they're good to have around. But keep in mind, certain species of snail might actually reproduce out of control and clog your pipes. So just be careful about what species you're introducing. The one that I use are fine. No More Monkeys 122 asks, what does fry mean? Fry are baby fish that are very, very, very tiny. So your fry are like your fish that are like the size of your fingernail. Yeah, host already answered that. Cool. So is trout the best fish species for Vermont? Should systems be moved inside as soon as outdoor temperatures drop? So let's go back to the fish slide. I'm not terribly familiar with Vermont's climate. I would say trout work anywhere as long as you can maintain these water temperatures. It doesn't matter where you are. In my situation, I live in inland Southern California. In the middle of summer, we're getting 100-degree weather almost every day. And it's really hard to keep water cool. So not a great place for trout. But I imagine Vermont is much cooler, so it'd be a much better place for trout. And also, do you need to move your system inside every day, every winter? No, not necessarily. If you have fish that can tolerate cold temperatures, then you could just pretty much let your system partially freeze over, put a de-icer on top of it, and the fish will survive under there. Their metabolisms will kind of slow down. They'll go dormant. And then you just remove all the plants and then just pretty much run the system without any plants over the winter. Just keep the water flowing. Don't let the pipes freeze. And just pretty much how you would manage a pond over the winter is how you'd manage an aquaponics. So just take the plants out and just keep the system running and don't really feed the fish, I would say. Can't really speak on this too much since I never get freezing weather here. The coldest it gets in the winter here is usually like 35 degrees, and that's like the coldest nights. So it doesn't really apply to me. I've never had to overwinter a system like that, but that's what I know of. So could fish tolerate 10 as long as you have a de-icer? Well, I mean, air temperature, yeah. Like, you know, of course, when it comes to water, if your water is below 32, it's going to freeze. So I would assume that your water is going to be in the 30s during the winter. So just make sure that it doesn't completely freeze. Like if the surface freezes, it's not a problem. Yeah, people have definitely used solar collectors. I would use that. I would look into that for sure. And in fact, the easiest way to build a solar collector is to take like a big piece of plywood, like a big sheet of plywood that's like 4x4, and coil a bunch of irrigation tubing on it, like make a coil of irrigation tubing, and then just use that as like a solar thermal panel and pass water from your sump tank through that. And that's it. And that'll produce pretty hot water. Just make sure you run the calculations of how much solar energy you're able to convert into thermal and actually capture to heat your system, and know how much your system is going to need. So just do the calculations. But people have definitely used solar collectors before, and it works. You can also probably use like those solar pool heaters. Yeah, solar pool heaters if you can get them secondhand. So any kind of solar water heating system, just make sure that you size it appropriately. Don't let the pipes freeze. That would be bad.
So I don't know if you're planning on talking about it later, but I'm a little interested in like the fish food itself and how DIY you can make that.
Yeah, that is a whole realm in and of itself. And I didn't cover that in this presentation, but I will tell you a bit about my experience with it. So one thing that you can do is grow duckweed, and duckweed makes a great component of fish food that's super easy to grow at home. You can literally grow it inside of a tote with your urine. Like, I'm pretty sure you could just pee in the tote, put water in there, and then have some duckweed, and the duckweed will feed off of the nutrients, and you'll have fish food. It's not like a complete diet for your fish. It doesn't have the right ratios of proteins to carbohydrates to fats. You would want to combine it with something else, like maybe worms or maybe black soldier fly larvae. A lot of people are getting into raising black soldier fly larvae, and they make an excellent component of fish food. And while also, serving as like, a means to recycle food waste. So I would say, duckweed is good to incorporate into a fish feed, a DIY fish feed. So is black soldier fly larvae. Another thing that would be worth looking into is azolla, which is a nitrogen-fixing aquatic fern. I think people have also used salvinia. So like a lot of those aquatic plants that are very vigorous and reproduce very rapidly can make a great fish feed.
Cool.
And I've also heard of people just feeding their fish chicken poop directly. There's this really cool system that I think this Kenyan inventor designed. And it's basically chickens integrated into aquaponics, where the chicken coop is above the fish tank and the chickens poop directly into the fish tank. The catfish eat the fish, the catfish eat the chicken poop, and then it runs an aquaponic system.
Yeah, I think I've seen that too. It was pretty cool. It was pretty big too. It wasn't like, a couple dozen chickens.
Yeah, it was decent.
Yeah, that's
So
cool.
cool stuff.
Yeah, that's all I got.
All right, for sure. So guess we can finish then. So yeah, let's talk about water chemistry really quickly and what affects it. So pH, I'm sure a lot of you guys know what pH is. It's just the measure of the acidity or alkalinity of the water. And this is what we want for aquaponics. Slightly acidic, 6.4 to 6.8. At this range, the fish are going to be happy, a mature and established microbiome will be happy, and your plants are going to be happy, because this is where the uptake of most nutrients that plants require is going to be optimal. This is where they're up. This is where they're going to be the most available. So when it comes to things that affect, if you have hard water, that's going to increase the pH. Nitrification reduces the pH. So nitrification is the nitrogen cycle in aquaponics. Denitrification occurs when you have anaerobic zones in your system. That is, again, regions in your system that are lacking oxygen, and anaerobic bacteria are beginning to grow. That is, bacteria that thrive in an oxygen-free environment. The compounds they produce are going to raise the pH of the water and keep it up. And normally when I see an established system with a high pH, that's a red flag right away. Oh, there's probably denitrification happening somewhere in the system. I'm sure the fish aren't healthy. I'm sure the plants aren't healthy. We need to find where it's happening and correct it. And you'll smell it many times because it stinks. Anaerobic zones in a system stink. Anybody who's dealt with anaerobic bacteria in any application, like especially if you're into like making comfrey tea and like weed teas and stuff like that, you know how that smells. So you'll smell it. You don't want that in aquaponics at all. Mineralization as well, which is again the breakdown of the solid fish waste into its mineral constituents, will also drop the pH. And also algae can lead to fluctuations in the pH because during the daytime, the algae will absorb CO2 from the water. This will cause the pH to rise because CO2 in water forms carbonic acid. So this will cause the pH to rise during the day. And then at night, the algae will start to die off, and this will cause the pH to drop because the decomposition of the algae and because photosynthesis stops overnight will increase the CO2 concentrations in the water, and this will therefore increase carbonic acid concentration. That'll therefore cause the pH to drop. So a good way to tell if you have excessive algae in your system is by testing the pH right before sunset and then right before sunrise. And then that'll give you an indication if there's like a fluctuation occurring. And if there's a fluctuation and there's lots of algae in your system, most likely that's why. A lot of, sort of like aquaponics, like the issues that you experience, you have to kind of go through a process of elimination, like making different observations, testing different parameters and sort of inferring what could be happening. So yeah, so for ammonia, fish excretion, of course, that's your main source of ammonia ideally. If you have any decaying fish food and organic matter, that will increase it too. Denitrification can also increase ammonia concentrations, and nitrification eliminates ammonia. So when it comes to decaying fish food in particular, if you're overfeeding your fish, then you're going to get increased ammonia in your system, and that's going to be an issue. So make sure you're not feeding your fish too much. Don't feed your fish the ideal rate all the time. Feed them what they will eat in 10 minutes. Otherwise, you're probably going to increase your ammonia levels in the system, and this can stress out your fish because it is toxic. And you don't ever want to see it higher than 0.25 ppms. I would say if your pH is lower than 7, slightly elevated ammonia is not a problem. Because what your test kits that test for ammonia are going to test for is total ammonia nitrogen, TAN. That is ammonia and the salt form of ammonia, the ionic form of ammonia, ammonia, NH4+. NH4+ is the form that ammonia exists in, mostly at a pH below 7. It's not very toxic. Gaseous ammonia, NH3, exists in alkaline water primarily and is very toxic. So if your water is alkaline on top of that, you don't want to see any ammonia at all. So nitrite, you never want to see nitrite. Nitrate. So yeah, nitrite, again, anaerobic zones can create nitrite, and nitrite most commonly will show up in a system if you have like a power outage or if there's incomplete filtration for some reason, like if your filters are, not working properly, if they're clogged, because they'll go anaerobic too, and also their filtration capacity will become reduced, because the nitrobacter and the nitrospira tend to be more sensitive than the nitrosomonas. And so, like, if you have an issue with your filter, you'll usually see nitrite appear first. So nitrite, usually power outage or problem with filter. And you'll also get ammonia during power outage, but you'll get both, really. And nitrate. So nitrification step 2 is what makes nitrate, or what produces nitrate in your system. Also mineralization to a much smaller extent. It's mostly coming from nitrification. And then your plants, of course, will remove it. Total dissolved solids, whatever range, as long as the plants are not suffering from any kind of salt toxicity, it's fine. Fish will excrete solids that contribute to TDS. Supplementation increases TDS, and plants will usually uptake some solids, and then if you're discharging water from the system, then that will also reduce your TDS. But generally, solids is not too much of an issue in aquaponics. I see solids levels fluctuate quite a bit in aquaponic systems depending on what stage in their life the plants are in. If you have very actively growing plants, then you'll start to see the solids go down. If your plants are starting to senesce or you just took out your plants, then you'll probably see the solids go up. So total suspended solids are your particulate solids that are suspended within the water column. And this is your broken down, this is your small particles of organic material in fish waste. So these come from fish, these come from organic waste generation. So the pee and the poop of other organisms in your system, like worms, you do want to introduce red composting worms. They'll help to deal with the TSS. And just bits of leaves that fall in the system, like that breaks down. This will create suspended solids. The roots of your plants will also capture some solids and filter them out of the water, where the microbes that exist a lot around the roots can deal with them, and also mechanical filtration deals with your suspended solids. Dissolved oxygen, you really want to have at least 5 parts per million in your water, and ideally higher. And the way that you get oxygen into the water is just by mixing air into it. That's it. That's why you want to have plenty of aeration in your system. Definitely, if you can, get an air pump. I'd highly recommend it. And again, as I said, install additional plumbing components on your system that increase how much splashing, how much bubbling, how much surface area of water comes into contact with the air. And then oxygen is removed from the system by respiration, by fish, and your whole aquatic food web. Aquaponics is an aerobic system. So all the biology in aquaponics is going to consume oxygen. And then your nutrient concentration. So whatever your target range is depends on the nutrients. So of course, and again, mineralization will increase nutrients, fish excretion will increase nutrients, supplementation will increase nutrients, and then plants and discharging from the system will remove nutrients. So when it comes to specific nutrient concentrations, If you're growing leafy greens, you want your nitrates between 40 and 80 parts per million. If you're growing fruiting crops, 10 to 20 parts per million. Potassium, kind of doesn't really matter too much. Phosphorus, I believe for leafy greens, you want 10 to 20. No, for leafy greens, you want like 5 to 10. And then for fruiting crops, you want like 10 to 20. Don't quote me on that. It might be 20 to 40, but I don't remember. But that's for phosphorus. And there are test kits for phosphorus too. I don't worry about phosphorus too much, but occasionally I will test for phosphorus. So as far as test equipment goes, this is the one that everyone uses. There are other ones out there, but I've used this one for almost 5 years now. I like it. It has plenty of tests in it, and it tests pH with a resolution of 0.2 and TAN, so total ammonium nitrogen, nitrite, and nitrate. So pretty much all you need to assess the health of your system. And then also, I like this solids, this pen that measures total dissolved solids. I really like other ones on the market. This one will last you a really long time. It's expensive. It's like $80, but it's durable and accurate. So nutrient supplementation. So your two main nutrients that are deficient in aquaponics and that are not present in sufficient quantities, typically speaking, in fish waste are iron and potassium. So the way that you add iron to your system is with chelated iron. This is pretty much an iron. All that chelated iron is an iron atom that is bound up with an organic acid. And these acids are, expressed in these abbreviations. One of them is DTPA and EDDHA. Don't use EDTA. EDTA is toxic. Don't use anything based off of citric acid or acetic acid. Those are antimicrobial. So 2 to 2.5 parts per million is a concentration you're shooting for iron. 2 to 2.5 parts per million. Potassium, I just use kelp extract. If you guys DM me and ask me about my supplementation protocol, I'll give it to you. I just didn't put it in here because it's going to vary a little bit depending on your system. But I have a protocol that I use, and it's going to depend on your product as well. But like for 100 gallons, add like a tablespoon of this every 3 weeks. Just a tablespoon of sewage extract for 100 gallons. That's pretty good. Additional supplements, so Epsom salt. It's great if you're growing fruiting crops because they will consume a lot of magnesium, and that I will dose at a rate of 1 teaspoon per 100 gallons. If you're limiting in phosphorus, use soft rock phosphate. So I also like to use azomite to supplement with a couple trace elements, and that's like I usually run that at like 1.5 teaspoons per gallon, and this works out like per 100 gallons. Sorry, so 1.5 teaspoons of the azomite per 100 gallons. That's what I use. For the chelated iron, I use 10% DTPA at a rate of roughly 8 grams per 100 gallons. And that's for like heavy iron feeding crops like kale, like 8 to 9 grams per 100 gallons. It's not that much, like you're adding like for a 100 gallon, 200 gallon system, it's like a small handful of stuff every 3 weeks. It's nothing compared to what you would use in a soil garden. You can really see how efficient aquaponics is because your main input is fish food. And again, if you can produce your fish food on site from your waste streams, you're even more efficient then. But yeah, so you do need to supplement. And I did talk a bit about aerobic digesters earlier. But if you don't have one of those, you're typically going to supplement once every 3 weeks. If you have an aerobic digester, it's once a month, once every 2 months, maybe even never. As long as your plants are healthy and productive, you might not even need to supplement if you have a really good mineralization tank that is, you're capturing all of your solids, you're mineralizing them in a mineralization tank. You might not even really need to supplement once at all. I have not supplemented my system at home in probably about 6 months. So not something you really need to do if you have a mineralization tank nearly as much. Issues. So common issues aquaponic systems face. And remember, if an aquaponic system, if you lack water flow, the moment that happens, the clock is ticking. You have 24 hours at most to respond to that. I have left work on a Friday and come back to Monday to dead fish, to hundreds of pounds of dead fish. I've seen it happen. You really have to be on top of it. So most common issues, water loss due to leaks and overflows. If you have an overflow situation that drains your fish tank, you're in big trouble. You need to be on top of that right away because not having water flow is one thing, Your fish might be able to survive for a day, but not having water at all, I don't know. I mean, depending on the fish, like tilapia might be able to survive a couple hours, but it'll stress them out horribly. Goldfish, probably not even like 30 minutes, like a couple minutes. So make sure you don't have an overflow issue, because those can be absolutely catastrophic. And designing your system with a sump tank will help to prevent the fish tank from overflowing and the water draining out. It's a great help. So pump and or power failures, that's why you need to check your system regularly. Make sure that the pumps are running properly, they're not clogged, they're not about to fail, there's nothing breaking, that you don't have power issues. If you expect a power outage, be on top of it. Have a contingency plan in place. Maybe have a battery backup or something of the sort. Maybe even take your system off grid. I mean, why not? You can totally run aquaponics off grid. You just want to make sure that you're able to provide power 24/7. That's the thing. Aquaponics needs power 24/7. Clogging happens all the time. I'm not at my home right now. I'm on vacation with my family, and my neighbor's been looking after my system. She calls me today. Hey, Andy, the strawberries look bad. You know, they're all wilty. And I'm like, oh yeah, I know exactly what that is. That's a clog. Good thing I'm being back. I'm going to come back tomorrow, because I'm going to need to be on top of that and fix that. Because especially if like your pipes that lead to your hydro modules are clogged, your plants can be dead within 24 hours in some cases if it's hot out and you're doing something like NFT. That's the other benefit of systems like DWC. Even if you have a power failure, you're not going to lose your plants. And even with the zip grow towers, because there's any media-based system, the plants will last longer. Water-based will last the longest. You know, your plants will start to get deficiencies and root rot eventually without power, but you know, they'll be fine for a while. Like, and even like with a media bed, they'll be okay for a couple of days if they're established. You know, but for NFT or anything that where the plants are not in a media or directly in water, you have like 24 to 48 hours. And then clogging in general can reduce the flow rate of water in your system, which is not good for your system. The lower the flow rate you have, the less oxygenation you're getting in your system, the less efficiently your filters can operate, and the less efficiently your plants can uptake nutrients. So you want to make sure there are no clogs in your pipes, no clogs in your pumps. Pipe clogs are not a huge issue unless you have a pipe with like a low flow rate, like emitters, for example. Like the pipes in my system that tend to get clogged are the pipes that feed directly into the top of the towers, because each tower is only getting a flow rate of about 7 gallons per hour, and that's nothing. So probably where my system is going to get clogged. If you have pipes with higher water flow, not as much of an issue there. And that's going to be most of your pipes that are sort of like operating the main loop in your system where water is flowing and the fish tank is getting turnover and stuff. So it's generally not a problem for like fish tank turnover and filter turnover clogging, but for like your hydroponic modules, it's a common issue. And then plant nutrient deficiencies are very common. 3 most common ones, nitrogen, iron, 4 I'd say. Nitrogen, iron, potassium, and magnesium are the most common. And nitrogen is easy to detect. Just look at your nitrate levels. And when it comes to nutrient deficiencies, fix your pH before you supplement. If your pH is unbalanced, then there's a good chance that there's enough nutrients in your system, but they've been rendered insoluble because of the pH. Because if the pH is too high, certain nutrients are no longer soluble, they'll precipitate out. If it's too low, same happens, but with other nutrients. So you want to make sure that your pH is in range and that you correct your pH before you add more nutrients to your system, before you increase your feeding rates. And remember, if you're going to change your pH, only 0.2 per day. If you want to push it and your fish are happy and you have tilapia, you really need to get your pH in balance. Maybe 0.5 per day, but that's only if you have a really hardy fish like tilapia that can handle rapid changes in pH. I would never do that with goldfish. And then pest infestations. It's about as common in aquaponics as it is in a regular, well-managed, organic, regenerative soil garden. I would say slightly less common than a typical organic garden because if you have a well-managed aquaponic system, then your plants are going to be really healthy. But yeah, sort of like anaerobic zones most commonly occur in filters and in media beds, especially if you have water pooling somewhere. That's usually where they occur, where the water flow is inadequate or there's not a lot of water flow because it's stagnant water. And if water is stagnant, just like in a stream or a river, it's going to become depleted of oxygen. So you want to make sure that you have good water flow and that there's no stagnant water in your system. because that'll lead to an anaerobic dead zone, even if you have enough filtration, even if you have enough turnover in your fish tank and turnover through your filters, like even if your water flows all set, your pump is sized correctly, make sure that there's adequate water flow in your system. And, again, like all of these things, I would say a solid 70 to 80% of this is from poor design choices and operator error and neglect. It's not something that just happens. If you are on top of maintaining your system, if you have a well-designed system, and if you're not making lots of mistakes, you're not really going to have many of these problems. It's just, aquaponics systems, again, are pretty stable. But like early on, you're going to make more mistakes. You may not design a system as well. You may neglect certain things or forget certain things. So typically, when you're just starting out, like operator error is a big problem, and you'll see the effects of it, and you can see like how many issues it can actually cause. So yeah, you'll get the hang of it. If you're just getting an aquaponics, don't worry, just keep with it, stick with it, and you'll start to see these kinds of issues less and less. I mean, I don't get them very frequently anymore. So yeah, when it comes to pesticides, I don't like using pesticides at all. I'm like an anti-spraying, pesticide spraying person. Like that's sort of my position on the issue. But I have used pesticides in aquaponics before, and just know that all pesticides are off limits unless otherwise specified. And here's your list right here. So generally speaking, the only things that are okay, like that are completely okay, are biological agents. So BT is okay. Lactic acid bacteria or lab is okay as long as you don't over apply it. Totally fine. Sort of like traps work just fine. Like I've used beer traps in my media beds before. Neem oil and its derivatives such as azadirachtin are okay in moderation. I've definitely overdone it with azadirachtin before because it is mildly toxic to fish. So in moderation, you can use neem oil or azadirachtin. Diatomaceous earth, apply it as a foliar. Don't let it get into the system. Iron phosphate bait, don't allow it to get in the system. For rodents, I've used ultrasonic emitters and chili pepper spray. Don't use an oil-based spray because if you get any oil into your system or soap, don't use soap either. It could actually coat the gills of the fish and interfere with oxygen uptake. So use a water-based spray if you're going to use chili pepper spray. And I would not use an alcohol-based spray either. Like try and make it as water-based as you possibly can. So yeah, these are your treatments. Also, potassium bicarbonate is fine for fungal disease of the leaves. So yeah, those are your treatments. I generally don't use pesticides at all. I do use lactic acid bacteria, but I mainly add it to the water because it also has certain benefits for the fish. For those of you who are familiar with KNF, you'll know what I'm talking about. But yeah, so free aquaponics resources. If you're on Facebook, check out the Aquaponics Anonymous group. There's another bigger aquaponics group, but a lot of the pros are in Aquaponics Anonymous. Some of the people in there are kind of like snoop, but they're very knowledgeable, and a lot of the people are really cool and they have great information. So the other resource that's great is the FAO Small Scale Aquaponics Manual. Literally just Google that exact phrase for the exact title verbatim. It's a free PDF online. It's like 250 pages, very information packed. You're going to learn a lot more reading that than you will from this one presentation. Then also the SRAC, that is the Southern something. It's like it's like a division of the USDA. The aquaponics fact sheets, those are very informative, and also Dr. Wilson Leonard's fact sheets. Dr. Wilson Leonard did a lot of the pioneering research into aquaponics, modern aquaponics, at least when it first came about. And also check out my YouTube channel. I have a couple videos on aquaponics. If you're just getting started, check out the video that I did on new mistakes to avoid. I covered a lot of them already in this presentation, but it'll kind of sum it up for you in like a 12 to 15 minute video. Don't remember exactly how long it is, but it's ballpark somewhere. And yeah, so also, if you really want to learn more about aquaponics, I am working on a comprehensive virtual aquaponics one-on-one course. It is going to be paid, but it is going to be reasonable. So if any of you are thinking about taking Murray Hallam's aquaponics design course, for example, this is going to be way, way, way cheaper. So if you're, and at this point, as Andy has said many times, information is free. Don't pay for information. pay for an education. There's a difference. You pay for somebody to teach you the material and work with you to help you learn. And that's what I would say. Use your money for if you want to spend money learning something. You can get all this information for free on the internet. Like just that FAO manual alone, that'll teach you everything you need to know to build and operate your first system, hands down. But if you want someone to teach it to you, then and do it for a reasonable price, then I will be offering that in the near future. Just to let you know. And follow me on Instagram. I'll have updates, and it's going to be very comprehensive. So just stay tuned. And thank you very much. There's my socials. Any questions?
That was awesome. I learned so much. I don't know if I trust myself to do this, but in theory, I understand it. So that's something.
Yeah, learning aquaponics is a very bumpy road for me. I feel like I still learn things every now and then after doing it for almost 5 years. But I would say if you keep at it for about 6 months, you'll get really comfortable with it.
Yeah, I think it makes a lot of sense how you broke it down, and like the different components were digestible enough that I can at least be like, all right, now I understand kind of why there's all of these different parts. It's just, I think for a lot of folks, myself included, like when you hear a bunch of new things, it's like when you start talking about it, it's like, all right, what does that thing mean again? And you're like, all right, yeah. Then you can move to the next thing, kind of start slowly putting it together. But that constant exposure is, I think, really helpful to figure out how to do this kind of stuff.
Yeah. Well, great. I'm glad you guys enjoyed it. Any more questions?
I think we might be good on the questions. This was fantastic. If you guys don't follow the Solarpunk Farmer on Instagram, you definitely should. Also, YouTube, check out his YouTube content. He's got some killer music in the background too. So I would definitely recommend going to check that out. For folks that are watching that don't know how you ended up here, you should go check out our podcast, the Porpoise Almanac. We just released an episode on Sunday with Nigel Palmer talking about KNF, or Korean natural farming. So it's very appropriate timing. So go check that out if you haven't. And next Tuesday, we're going to be doing some stuff with working with sheep's wool. So going in a different direction, but I think also really important and useful skills. So Solarpunk Farmer, Andy, this has been great. I appreciate your time, and hopefully we'll have you on soon.
Thank you, and thank you for the support and for inviting me on. Much love. Have a good one.
Thanks, bud. All right, folks. I think that pretty much wraps it up. If you're not familiar with us, go check out our content. Like I said, we're on Instagram, Facebook, YouTube, Twitch, obviously, and a bunch of other places. So go check out our content, and hopefully we'll see you around again. Thanks, guys.